Over the past few decades, Turkey has demonstrated a major transformation in its defense and aerospace industries. From a mere consumer of technology, the country has gradually transformed into a producer with advanced engineering capabilities. One important milestone in this journey is Turkey's involvement in the assembly and development of a new generation of jet engines. This step is not just another industrial project, but rather a symbol of the national ambition to achieve technological independence and strengthen its position in the global aerospace supply chain. Modern jet engines are known as one of the most complex systems ever created by mankind, combining materials, science, aerodynamics, and digital intelligence into a single, high-precision unit. The latest jet engines are designed to meet the demands of fuel efficiency, low emissions, and high performance. The technologies used include advanced composite materials that can withstand extreme temperatures, as well as innovative cooling systems to maintain operational stability. Furthermore, the use of additive manufacturing, or 3D printing, enables the production of components with complex shapes that were previously difficult to manufacture. This technology not only reduces engine weight, but also increases efficiency and service life. A new generation of jet engines is designed to meet the demands of fuel efficiency, reduced carbon emissions, and high performance. Compared to previous generations, these engines utilize lightweight composite materials, heat-resistant metal alloys, and more efficient aerodynamic designs. Technologies such as geared turbofans and low-emission combustion systems are setting new industry standards. On the production line, every engine component, from the turbine blades to the combustion chamber, is manufactured to extremely tight tolerances. Even microscopic deviations can impact the engine's overall performance. Therefore, precision is key at every stage of production. Modern production lines rely heavily on automation. Industrial robots are used for tasks such as precision, welding, drilling, and visual inspection. These systems not only increase production speed but also reduce human error. Critical components such as turbine blades are manufactured using additive manufacturing techniques, metal, 3D printing, and high-precision CNC machining. The materials used must be able to withstand extreme temperatures of up to thousands of degrees Celsius. Jet engines are assembled into separate modules, such as the compressor, combustion chamber, and turbine, before being combined into a complete unit. This modular approach increases production efficiency and simplifies maintenance. However, the human role remains crucial. Experienced engineers and technicians are responsible for monitoring, decision-making, and adjusting processes that cannot be fully automated. In the aviation industry, safety is a top priority. Every engine must meet stringent international standards, including certification from agencies like the FAA and EASA. The inspection process is multi-layered, from material inspection to final testing. Non-destructive testing technologies such as X-rays and ultrasonics are used to detect internal defects without damaging components. This ensures that every engine part is in optimal condition. Jet engine production faces various challenges, including the need to reduce carbon emissions and increase energy efficiency. To address these challenges, the industry is developing alternative fuel engines such as hydrogen and sustainable aviation fuels. Furthermore, the integration of artificial intelligence into the production process enables real-time data analysis to improve efficiency and predict potential failures before they occur. The latest generation of jet engine production lines is a blend of high technology, continuous innovation, and human expertise. From digital design to final testing, every stage is designed to produce engines that are not only robust and efficient, but also safe and environmentally friendly. This progress demonstrates how the aviation industry continues to evolve to meet the needs of an increasingly connected world. Behind every smooth flight lies the hard work and advanced technology at work relentlessly on the production lines of modern jet engines. Turkey, through its partnership with Boeing, has begun integrating this technology into its production processes. This marks a significant leap from conventional manufacturing to a high-innovation industry. Since the early 2000s, the Turkish government has consistently invested significant resources in the development of high-tech industries. Companies such as Turkish, Aerospace Industries, and TEI have spearheaded strategic projects, including the production of jet engine components. The collaboration with Boeing has opened access to global manufacturing standards and provided invaluable knowledge transfer in the next-generation jet engine project. Turkey is not only acting as an assembler but is also beginning to play a role in the design of critical components such as high-pressure turbines and efficient combustion systems.